Hi students, welcome to the science class. In last class we studied about what is matter, what is the types of the matter, that is what is meant by the compound, what is meant by the element, isn't it? What is meant by the mixtures, what is meant by the solutions, what is meant by the colloidal solutions, isn't it? What are the properties of the colloidal solutions, what are the properties of the solutions? These are all we know in the last class, but in the today's session we are going to continue with that theory, that is nothing but we studied under the chapter of atoms and molecules what is present in a compound, what is a compound made up of, isn't it? What is element is made up of. That is, in this session we are going to study what is meant by the smallest particle of an element, isn't it? And what are the theories comes in that session we are going to study in today's session. So when we are going to divide any object, now I am considering a chalk piece. If you are going to divide a chalk piece, we can divide it into two pieces. Again, if you are taking one piece and again if you try to divide it, yes, we can possible to divide it into two pieces. If you are go on continue with the division of this chalk piece, you can get lastly a small part, isn't it? A small part of a chalk piece. Again, if we try to divide that small particle of the chalk piece, yes, it is possible under the electronic microscope, but if you are go on dividing under the electronic microscope the particle of the chalk piece at a one stage it cannot be divided, we can't divide that particle. So what is that particle, we are going to call, so that is studied in this session. So around 500 BC in our India, the Maharshi Kanada, who was first postulated a theory about the small particle which is present in an element. He tried to say that he tried to make an theory about the small particles which are present in an element. He told that if go on we are dividing any particle, any element, any compound, we come to know at a one point the particle can't be divided, and that particle he said that is an paramanu. He named that particle, that the final particle which we can't divide, he named that as an paramanu. We have to prove that the first scientist, the first philosopher who said about the smallest particle of an element, that is he named as it is an paramanu. Then after onwards, after the years, the two Greek philosophers, Democritus and Leucippus, they are going to continue the study of the Maharshi Kanada. They make the continuous study of the philosophies or the theories of the Maharshi Kanada and named that the smallest particles which are present in an element, that as atoms. After onwards, Kanada named that smallest particle as an paramanu, but after the continuous study of that theory by the Greek philosophers Democritus and Leucippus, they named that smallest particle as atoms. Is it clear? Then after onwards, after some days, the Anthony Lavoisier, he continued the theory of that atoms. He makes studies on the theories of the atoms. He makes some laws on a chemical combinations or laws on a chemical reactions. That laws are nothing but laws of conservation of mass and laws of constant proportions. Actually, the Anthony Lavoisier made 5 major laws, but in your syllabus we have to study only the major 2 laws of chemical combinations, that are nothing but law of conservation of mass and law of constant proportions. So what are these laws of conservation of mass and law of constant proportions? What it states, what is the use of that we study now. Law of conservation of mass. So you have to remember here, these are very important laws. These are the fundamental laws for the chemical combinations. You have to remember, if any chemical reaction, if you are going to study, these laws must be holds good. Why? Because these are the fundamental laws of chemical combination. So first I am considering here the law of conservation of mass. So what is the statement of the law of conservation of mass? in any chemical reaction, the mass of the reactant always equal to the mass of the product. Mass neither can be created nor can be destroyed. So what is the statement, first statement of the law of conservation of mass here? In any chemical reaction, so if we are going to consider any chemical reaction, first we can consider the reactants, isn't it? So I am considering one example here. If you are going to make a solution of a sugar solution, if you are going to make, isn't it? So you are considering 10 liter of water and 500 grams of sugar, you can get a sugar solution. But what is the theory, what is the theme of the law of conservation of mass here? So the reactants, what are the reactants here? The water and the sugars are the reactants. What is the product here? The product is nothing but the sugar solution. So what the law of conservation of mass says here? The mass of the reactants, mass of the sugar plus mass of the water, mass of the reactants are always equal to mass of the product. The product is here sugar solution. So and mass is neither can be created nor can be destroyed. In an overall reaction, there is a no loss of mass or there is a no gain of mass. There is always equal. That will be stated by the law of conservation of mass. Once again I am repeating here, what is the statement of the law of conservation of mass? It states that in any chemical reaction, the mass of the reactants are always equals to the mass of the product, and mass neither can be created nor can be destroyed. For example, if I am considering A is a reactant reacted with another one reactant B, the product we get as a AB. I am taking general example here. If A is any reactant will react with another one reactant B, it makes a product called AB. So according to the law of conservation of mass, what is here? The mass of the A plus mass of B is always equal to mass of AB. Why? Because according to law of conservation of mass, mass neither can be created nor can be destroyed. We are adding both the reactants here. So in the solution or in the product, the mass of the product must be equal to the sum of the masses of the reactants. Is it clear? So once again I am repeating here, what is the law of conservation of mass states here? In any chemical reaction, the mass of the reactants are always equal to the mass of the product. So in any chemical reaction, the mass of the reactants are always equal to the mass of the product. So if you are taking any example here, any chemical reaction here, the mass of the reactant always equal to the mass of the product. So in the question arises in your mind, if we are taking the reactants in which some of the in a reaction, the sum of the mass of the reactants will be eliminated in the form of the gas, what happens that? So if you are going to make that reaction, if you are going to check the mass of the reactant at that time, you have to close the mouth or the mouth of the reactant box very closely, very tightly. That can stops the elimination of the gas in the jar only. Then only you can calculate the mass, you can get the product, isn't it? So then that time only the law of conservation of mass holds good in that reaction. So what it states, the law of conservation of mass, it is nothing but in any chemical reaction, mass of the reactant is always equal to mass of the product. Is it clear? And mass neither can be created nor can be destroyed. So another one, the fundamental law of chemical combination is nothing but law of constant proportions, that is also stated by the Anthony Lavoisier. So what it states, what is the statement of the law of constant proportions? See here, in any chemical reaction, compounds always contain the same elements present in different proportion of mass. So in any chemical reaction, compounds always, in any chemical reaction, if you are going to take any chemical reaction, the compounds always contain the same elements present in the different proportion of mass. So what it says, if you are going to take a compound, what is compound? Already I told that compound is a chemical combination of two elements. So water, H2O, it is a compound. So H2O, what it says, the compound contains more than two elements in a definite or a different proportion of mass of different elements. I am taking H2O as a compound here. So H2O is made up of two elements that are nothing but hydrogen and oxygen. According to the constant law of constant proportions, and a compound is made up of, and compound is always contain the same elements present in the different proportion of mass. A water, I am taking for example, one water molecule contains H2O. If you are going to consider 2 grams of hydrogen, 1 oxygen is present. So if you are going to consider 16 grams of water, if you are going to consider 18 grams of water, so in the 18 grams of water, mass of hydrogen it is 2 gram and mass of oxygen it is 16 gram. Is it clear? Why? Because what it states here, the elements which are present in the compound are present in the constant or different proportions of masses. So I am taking H2O as an example. Here hydrogen is present in 2 gram and oxygen is present as 16 gram. If you are going to take 36 gram of the water, it is a compound. The mass of the hydrogen here is 4 gram and mass of the oxygen here 32 gram. So they are present, the different elements are present in a definite ratio, and it has a different masses, and the different elements has different masses. We have to clear here. So the one question arises in your mind. If we are going to take H2O, which hydrogen and oxygen are present in a water, is the hydrogen and oxygen are present in equal masses in the water? No, it is not equally, because as we know already, one molecule of water contains 2 hydrogen atoms and 1 oxygen atoms. Based on this theory, according to the molecules present in a water molecule, that the masses of the molecules also depends here. Is it clear? So different molecules in a compound, different elements has a different mass of molecules. So based on these two laws, the Dalton atomic theory passed. So Dalton makes an atomic theory. So why? Because the smallest particle of the element, it is called it as an atom by the Greek philosopher Democritus and Leucippus. Based on this theory, Antonio Lavoisier made as the laws of chemical combinations. So by studying laws of chemical combination, Dalton makes some atomic theory. He states some atomic theory. What is the atom? What its postulates? So now see the postulates of the Dalton's atomic theory. What are the postulates of the Dalton atomic theory? All matter, whether compound, element or a mixture, is composed of small particles called atoms. If you are going to take any matter, if it is an element, if it is a compound or if it is a mixture, that all matter is made up of small particles, and the small indivisible particles are called it as atoms. First postulate of the Dalton theory. You have to remember here in your examination, 3 to 4 marks question should be asked on this. Write the postulates of the Dalton's theory. So you have to remember, you have to understand the theories, the postulates. It is very easy to write in your examination. So what is the first postulate of the Dalton atomic theory here? In all matter or element or a compound or a mixture, it is made up of small indivisible particles that are called it as atoms. Atoms are, second postulate here, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. See here, the second postulate here, atoms are the indivisible particles. They are the last steps. They found by the division of last step. It cannot be divisible further. So atoms are the indivisible particles which cannot be created or destroyed in a chemical reaction. That is the second postulate of the Dalton theory. So what is the second postulate of the Dalton theory here? The atoms are the indivisible particles that cannot be created or nor be destroyed in a chemical reaction. And the third postulate here, atoms of a given element are identical in mass and a chemical particle properties. Atoms of a given element are identical in mass and in a chemical properties. So atoms of a given element, if you are going to consider atoms of any element has identical in mass. For example, you are taking one hydrogen element here. If you are another one taking, I am taking here one iron rod, and again I am taking another one iron rod. If you are going to take an atom of an iron, one piece of iron, and again you are taking considering another one atom of an another one iron, the mass of the atoms of two iron rods, if you are going to take any type of the iron material here, so the atom of the iron always has the identical mass and identical chemical properties. So every atom of an iron has the same mass and the same chemical properties. That is the third postulate of the Dalton theory. Once again I am repeating here, every atom of any element has a same mass and the same chemical properties. And a fourth postulate of the Dalton theory here, atoms of different elements has a different masses and a different chemical properties. So if you are going to consider different elements, so again I am considering simple example here, that is nothing but the water. It is a compound, it is made up of the two elements called hydrogen and oxygen. So what is the third postulate says the atoms of an element has the same masses and the same chemical properties, but the different atoms of the different elements I am considering here atom of an hydrogen, one atom of an hydrogen and one atom of an oxygen. So the mass of the hydrogen is different from mass of the oxygen. Mass of the hydrogen is very different from the mass of the oxygen, and the chemical properties of the hydrogen is very different from the chemical properties of the oxygen atom. So what is the fourth postulate here, atoms of the different elements has a different masses and a different chemical properties. Is it clear? If you are going to take atoms of different elements, I am taking the one atom of hydrogen here and one atom of the oxygen. The mass of the hydrogen atom is different from mass of the atom of the oxygen, and the chemical properties of the atom of the hydrogen is very different from the chemical properties of the oxygen. That is the fourth postulates of the Dalton theory. Next one is here, atoms combine in the ratio of small whole numbers to form a compound. So if they are going to make a compound, I am taking one compound here, water. It is a compound made up of two elements. Why I am taking, it is a very simple example, that's why I am taking here H2O. It is a compound that is made up of the two elements called hydrogen and oxygen. So fifth postulate states here, atoms combine in the ratio of small whole number. They are combined in the ratio of small whole number. Hydrogen, the atoms of the hydrogen is 2, oxygen is 1, that is 2 and 1, it is a small whole numbers. They are combining in the small whole numbers to form a compound. If the two elements are going to make a compound by the chemical reaction, they are combined in the small whole number. Is it clear? And the last postulate here, the relative number and a kind of atom are constant in a given compound. The relative number and a kind of atom are constant in a given compound. What it means? The relative number, I am considering again H2. So what is the last postulate of the Dalton theory here? What is that? That is the relative numbers and the kind of the atom are constant in a given compound. So I am considering water as a compound. The relative number, if you are going to take 16 gram of the water or the 36 gram of the water, the relative number of the elements present in a water molecule, it is always constant. Is it clear? So it always the ratio of the water molecules, the ratio of the elements which are present in the water molecules always in the form of 2:1. I am considering water molecule here. The one water molecule contains 2 hydrogen atoms and 1 oxygen atom. The ratio is 2:1. If you are going to take the 16 grams, if you are going to take 1000 grams of the water, in that case also the relative number of the atoms of elements which are present in a compound, it is always constant, that is in the ratio of 2:1. So that is the last postulate of the Dalton theory, that is the relative number and a kind of atom are constant and in a given compound, and the type of the elements also constant in a given compound. If you are going to take 1000 liter, 10,000 liter, how much amount of the water you can take, the ratio of the element present in that compound, it is always a constant, that is the ratio 2:1. That is the last postulate of the Dalton atomic theory. So then one question arises in your mind, after knowing the atomic theory, what is atom here? What is atom? So atoms are building blocks of all matter. These are the building blocks. If you are going to build a building, what you are going to use? Blocks, isn't it? You are going to use a small blocks or small stones like that. For example, I am considering a chalk piece. So the chalk piece particles, if you are going to make smallest particles of the chalk piece, these are, if you are taking it as an atoms, the atoms are the building blocks of the matter. So the smallest particle of the chalk piece, it is a building block, it is a block of the chalk piece, it is made up of the small chalk piece particles. So atoms are the building blocks of the all matters, and these atoms are cannot seen by the our naked eyes, and also that cannot be seen by the electronic microscope. You have to remember here, the atoms of the element that cannot be seen by the electronic microscope also, and the size of the size of the atom is very small. What is, if you are going to imagine the size of the atom, the radius of the atom, it is comes in the nanometer. So they are present in the nanometer size, that is nothing but it is equal to 1 nanometer is equal to 10 raised to minus 9 meter. It means if you are going to consider a size of an atom, that is equal to 0.1 2 3 4 5 6 7 8 then 1 9, so meter, so 0.0000001. So this, it is the very smallest, it is a very small, we can't see even by the electron microscope. So the atoms are very small in size, and the radius of the atom will be measured in terms of 10 raised to minus nanometer. So and also these atoms are the very important, they are take part in a chemical reaction. So when any chemical reactions happens, the chemical reaction started with the atoms, because the building blocks of the any matter is the atom. So from that atom the chemical reactions are started. So once again I am repeating here, what are atoms? Atoms are the building blocks of all matter. So it is very small, the last smallest particle of any matter, it is called it as an atom. So atoms plays a very important role in a chemical reaction. So how we are going to make, how we are going to name the atoms, how we are going to find out the atoms, so that will be studied in the next class. That is nothing but the naming of the atoms. Naming of the atoms, or we are going to give the symbols for the atoms. How we are going to give the symbols for the atoms, that we can study in the next class. Thank you.